In this video, we will be implementing the start of font rendering in the broader scope of a new series on the subject of implementing a text editor from scratch. My name is Emil, and before we jump into the coding itself, let's take a quick look at an illustration of what we are trying to accomplish. To start off, we will be implementing a parser for the TrueType font file format .ttf, as well as a simple rasterizer just to test our code. But first, let's start off with a quick overview of what we're trying to accomplish with font rendering. Then later, we will talk about the goals of our text editor. This is a character for the number 8. Our goal is to write a program that reads a TrueType font file and renders a glyph like this. So, how do we go from a raw file to a fully rendered glyph? The font file contains a bunch of information divided up into tables. These tables have all the information we need to map a char code to an offset containing the glyph information. Glyphs comes in two flavors. The first is a simple glyph made up of points and a list of contour ends. The other kind is a compound glyph. A compound glyph is a collection of simple glyphs. These glyphs are transformed using a matrix to position them. For example, a double quote can be created out of two single quotes. Or a semicolon can be created from a comma and a period combined into one glyph. Now we need to read the points out of the glyph information, so that we can start applying all the operations to render the final image. What you're seeing on the screen at the moment is all of these individual points plotted. As you can see, they make the outline of the character for the number 8. But this information in of itself is not enough to actually draw the outlines or fill in the shapes. Firstly, how do we know which shapes are to be filled in and which are to be cut out? Second, how do we know which dots belong to which shapes? Here is how. The green dot represents the start of a contour. The cyan dot represents the end of a contour. Using this information, we can determine based on the order of the dots, which dots belongs to which shapes. To illustrate this, I will color each individual shape as a different color. As you can see, we have 3 distinct shapes, blue, purple, and yellow. You will notice that the yellow and purple shapes are running counterclockwise, starting with the green dot and ending with the cyan dot, whereas the blue shape on the outside is running clockwise, again starting with the green dot and ending with the cyan dot. This is referred to as winding notation. The counterclockwise winding indicates that the 2 center shapes should be cut out of the bigger blue shape. Drawing lines between the points should make this more clear. As you can see, the yellow and purple shape should not be colored in. Only the outside shape between the blue and yellow shape, or between the blue and purple shape, should be filled in. Now at this point you might be asking yourself, man, that's one ugly 8. It's not even very round and it's very boxy. This is because there is a third piece of information provided by the file. Whether a point is on a curve or not. If 2 points that directly follow one another in sequence are marked as on a curve, they should be interpreted as a Bezier curve, and forgive me for butchering that word. But we need to apply the quadratic Bezier curve ourselves. Using an algorithm, we can insert control points that looks like this. Now, that might not look like much of a difference, but it's important to actually make the curves work. Using this information, we can feed it into the quadratic Bezier curve formula to create our rounded shapes. Now, this kind of algorithm uses an argument, essentially defining how many points you wish to add, or in other words, what the resolution is. The higher the resolution, the higher the quality. But it's a bit hard to see what's going on if we use a high number of iterations. So, for the illustration, I will only go up to 4, but in the final implementation that we will be using in the text editor, we will be using a resolution of 15. So yeah, here is the shape with a resolution of 1. Let's take a look at a resolution of 2, and a resolution of 3, and finally a resolution of 4. And as you can see, now that looks like a proper rounded 8, all curvy and nice. The next step would be to go about rasterizing the shape. All this is essentially to color in the shapes. There are a few approaches to doing this. Some good approaches are to use either an edge buffer or a scanline rasterizer. But there are many techniques. In our case, we will be using OpenGL to render our text editor. This means I will want to convert my shape into a bunch of triangles that the GPU can then draw on the screen. To do this, we need to triangulate the shape. But when there are so many points on the shape, it can be a bit hard to see what's going on. So let's take a step back to a more blocky version of the 8. In this case, we're going to just use an algorithm to convert these individual shapes into one list of triangles. As you can see, indicated by the white lines. This is how it would look. Every point is used to create a bunch of individual triangles that can then be sent to the GPU to render as one solid shape. I am going to up the resolution one notch at a time so you can see how the triangulation changes as the shape becomes more round. Now I will fill in the triangles, but every second triangle will be a different color, alternating between orange and green, just to give you an idea of what's going on. Finally, if we fill in all the triangles with just plain white instead of different colors, we will get something that looks like a rendered glyph. Now, if I remove the points in the background, we get this. But because we used a resolution of 4, we see that there are still some flat spots around the curves. So here is the final form rendered with the curve set to 14 iterations. While we look at the time-lapse of the implementation, let's talk a bit more about the goals of this text editor. I personally really like command mode text editors. I find that they can be very productive and also very good for your physical health when it comes to things like carpal tunnel syndrome. But I do have dyslexia and that makes it really hard to learn them. This drastically complicates using them on a regular basis. So my goal is to create a text editor that is designed for my unique situation. It's also a fun challenge and exercise to try and implement something like this. Some secondary goals is to create a text editor that responds very fast. I really dislike it when you're typing and you can feel the milliseconds between every keystroke. Another secondary goal is to try and create a universal interface for my tooling. If the entire text editor is command mode based, so you're only using the keyboard, it would be great to have some way of creating plugins very easily to extend the text editor with tooling in a rapid fashion. For example, if I was working on my hobby compiler, I would print out my abstract syntax trees with diagrams or charts or whatever. And so that's kind of all the goals I have here. Just a quick overview of what this code is doing, and then I'll leave you be to just listen to some music while you watch. So we're loading up a bunch of tables out of the TrueType font file, and the head file, the CMap head table, the CMap table, and then so those will the CMap table will map char codes to glyph offsets using a LOCA table. And you will take that information to then read out the points, and then you would just render those. I had a lot of bugs when trying to make this work, and there's two major documentations on this subject. The first is by Apple and the second Microsoft, and at some points they don't line up, and at some points they were both wrong. So you'll see me laboring away on a small subset of code at quite a few points, trying to figure out why these data types are not lining up. Eventually I figured it out and it worked out. And then at the end there were quite a few bugs with the curves not working properly, so that was kind of painful, but in the end, it worked out. So if you do enjoy this, please do subscribe, and if you have any suggestions in terms of what content to make, I will be continuing this series in the next episode, but any other content, please do feel free to suggest that. And thanks for watching, and I'll see you next time.